What's up YouTube, it's Selza with another tutorial. Today I'll be showing you guys how to make a zipline using CV2 in Rec Room. Let's get straight to it. We press F on menu, then we go to palette and we go to the search bar. We're going to search up laser pointer. Then we're going to configure the circuit board and we're going to scroll down to delete all board content. And we're going to configure this laser pointer component and change the length to about 5. Now we're going to get an interaction volume. Then we're going to configure the circuit board, scroll all the way down and delete all board content. Then we're going to configure the interaction volume and we're going to change the interaction prompt to start zipline. So now we're going to configure this circuit board again. We're going to scroll down to port groups. We're going to add a port group and we're going to name it CV2. We're going to click on the drop down. Then we're going to go to inputs and we're going to add an input port. We're going to change this first one to laser pointer. And we're going to name it laser pointer. Then we're going to add another input port. We're going to change it to a float. Then we're going to name it time to end. Then you could do parenthesis S parenthesis for seconds, how long it takes to get to the end of the laser. We're going to add another input port. Then we're going to do a force. Then we're gonna add another input port. We're gonna change it to a float. Then we're gonna name it force. Parenthesis speed. We're gonna make one more add input port, which will be a bool. We're gonna name it body position. So this is basically telling us if this is false, then we would be using hand position. Wherever our hand goes, we'll swing around the zip line. If it's on true, then our body will just ride along this laser pointer. So first, we're going to wire this yellow output on this laser pointer to the input of this interaction volume. Then we're going to wire this time to end, and I'm going to make it 5 seconds. Then the force speed, I like 40. Now we're going to edit, go to tools, and we're going to go on top left and edit this interaction volume. When you edit this interaction volume, you should see an input with 4 outputs and then an output. So first, we're going to need an event receiver. Then we're going to configure it and change it to on use. And we're going to get delay chip. We're going to get a float variable. We're going to get a time get precise seconds. Then we're going to get a subtract, a less than, an if chip, a velocity set, a get local player, a divide chip, we're going to clone this event receiver and we're going to put it right under the less than, and we're going to configure it and change it to update 30 hertz. Then we're going to get a bool variable, put it under the update 30 hertz. We're going to clone this less than and put it under the divide. Then we're going to need a distance chip. We're going to need 2 of them. Then we're going to need a laser pointer get length. Then we're going to need a multiply, a get forward vector, a get position, a vector 3 scale. And the vector 3 scale basically multiplies the vector by a scalar. So it makes the output vector you get and it shrinks it using whatever scalar you have. We're going to get an add chip. Then we're going to get a subtract chip. Then I'm going to go up a little bit and we're going to get a player right hand and left hand position. We're going to get an if value. We're going to get a player body position. And we're going to get another if value. These if values basically state if the condition is true, then it will output then in the result. And if it's false, then it will output the else in the result. So now we can get to the wiring part. So let's start at the bottom section. the laser pointer get length. The target will be this output laser pointer on the circuit board. Then the length will be multiplied. Then the bottom value on multiply will be wired to the quotient on the divide, and the product of the multiply will be wired to the scalar. The value on the vector 3 scale will be wired up to the get forward vector. The result of the vector 3 scale will be on the add bottom value, and the top value will be the get position output. Then the target of the get position will be wired up to the laser pointer as well as the get forward vector. The sum of the add will be on the top value of the subtract, and the bottom value of the subtract will be on the second if value at the top. The difference of the subtract will be the velocity of the velocity set chip. The multiplier of the velocity set will be the force speed. The target will be the get local player. And the input of the set velocity will be the then on the if chip, with the input of the if chip being wired to the update 30 Hertz. The condition of the if chip will be wired to the result of the less than. The B value on the less will be connected to the time to end. And the A value will be the difference of the subtract. The difference will also be wired to the top value on the divide. And the bottom value of the divide will go to the time to end. The top value of the subtract will go to time get precise seconds. And the B value will be the flow variable output. The value on the time get precise seconds will be the input of the flow variable. And we're going to wire the output of the onUse event receiver to the input of the run delay. Then we're going to make the delay on this delay chip 0.1. The after delay will be the flow variable input. Then the output of that flow variable will be the input of this bool variable. The input of this bool variable will be on the result of the less than, while the output of that bool variable will be on the if value at the top. The less than A value will be wired to the top distance, while the B value is connected to the bottom distance. So the distance on the A value at the top will be wired to the right hand position. The B value on the distance will be wired to the get position of the laser pointer, as well as the B value on the bottom distance will go to the get position to the laser pointer. Then the A value of the bottom distance will go up to the left hand position. The left hand position output will go to the else on the if value, and the then will go to the right hand value. The output of the if value will go to the else on the second if value chip, and the output of the player body position will go to the then on the if value. Then the if on the if value will go down to the body position input on the circuit board. So here's a brief image of what the wires look like for this circuit. Since this body position is false, when I click this interaction volume, it will put me up to the zip line and use my hand to ride along across. And when you get to the end of the laser, it will drop you, and then you could restart. And if we were to change this to true for the body position, and we hit the interaction volume, it would just make us ride along across on our body. So this was definitely more of a complex circuit. So this circuit is basically stating that we'll get the forward position of the laser pointer, and we will scale that vector, and we'll subtract either the body position or the hand position depending on what input we have for our if value. So if our if value is true, then our body position will be the one that's being measured, and if it's false, then our hands will be the ones that's being measured. And that was a tutorial on how to make a working zip line in Rec Room using CV2. Thank you guys for watching. See you guys in the next tutorial. And this is my profile. Subscribe.